Hello there. Let's do a problem involving compound interest. Nisha has a CD, certificate of deposit, with $1,000 and it earning 1.5% interest compounded annually. I'm underlying the important numbers here. And we want to write the next now rule and the y equals rule. First thing I'm going to do is divide that 1.5% by 100. And we got it converted into a decimal. And then we're going to apply this interest rate to that $1,000. So when I multiply the current amount now times 0.015, that counts the interest. Then we need to tack on whatever the previous amount was. Now, I can actually gather like terms because both of these are with now. I can treat that as a single term. And the number that's out in front of the second one is a 1. That's 1 times now. So we're going to simplify this. So the 0.015 from up here comes here, and the 1 from over here comes down to this position. So I'm just taking my current amount and multiplying by 1.015. And all next now rules need a starting at value. Alright, we successfully have the now next form of the equation, and it's in this very nice format where it's just the now times a number starting at. So I can convert this to a y equals rule. Starting at value comes out in front, that's the y-intercept, and whatever we were multiplying by each time, that becomes the base over here, raised to the x power. That x is there as an exponent because this is exponential growth. In this next part, we're going to fill out a table with some of the... shaking all over the place here. Fill out a table with some of the values for each year. So starting in year 0, we start with $1,000. Now I'm going to type this rule into my y equals and look at the table. I could also enter in this rule, seeding the 1,000 and doing answer times 1.015, pressing enter, pressing enter, pressing enter, and getting these values. So this first one is going to be $1,015. Then I'm going to take this amount and allow that $1,015 to grow by 1.5%. So it didn't just go up another $30, but the interest got to earn some interest. So I have this little bit amount of cents left over here. It was actually 0.225, but I'm rounding. I am, however, going to use the 0.225 to predict the next value over here. And then I just keep pressing enter. But I have to watch out. Previously we were going 0 to 1, to 2, to 3, to 4, to 5, to 6, to 7, to 8, to 9, to 10. This jumps all the way. So I have to skip a bunch of numbers here and jump up to stage 10. So 10 years in, I am at $1,160.54. It's money, go to 2 decimal places. So this 1.5% is pretty lousy. How long is it going to take to have at least $2,000? Let's write the equation first. So this is the format for the amount of money. There's going to be a 2,000 involved in here. And I'm not setting them equal to each other here because I don't want to know when I have exactly $2,000, but when I have at least $2,000. So I need an inequality. This side here, this is the amount of money that I have. So I need the amount of money to be at least to be larger than or equal to the 2,000. So the inequality faces that direction. Now we're going to go about trying to find this in a table. So I typed that in, I'm scrolling down my table, and I had to go pretty far. I'm all the way down in the 40s, so it looks like it happens between 46 and 47. I need for the interest to hit the 47. So to show my work, I'm going to copy what that portion of the table looks like. And because we're using this word at least, and the interest is going to be only compound is not during the year, but at the end of the year, I got to go to this 47. So I need to wait at least 47 years. So So to write that sentence, she's got to wait at least 47 years until she has $2,000, until her money doubles. Thanks for watching. Character and Scholarship for Life.